The method I'm going to describe now is the line point intercept method. Line point intercept is a rapid and accurate method for quantifying soil cover, including vegetation, litter, rocks, and biotic crusts. These measurements are related to wind and water erosion, water infiltration, and the ability of the site to resist and recover from degradation. We begin this method by starting at the zero end of the line, always reading from left to right, and always standing on the right side of the line so that the numbers on the tape are right side up. So moving to the first point, what we do is find the first point on the tape, keep your pin vertical, always vertical to the ground, and keep the pin height roughly 6 inches off the top of the tallest vegetation at that point, or the soil surface at that point. We let the pin fall freely down to the ground, and the object is to aim for the point on the tape and not to specifically try to end up right next to that point. We're just using the point as a target. If the point doesn't fall exactly where you want it to, that's okay. We just let it fall. This is a random point. We're just letting it fall and calling it where it falls. So I let it drop. Notice it's about an inch away from the line, but that's okay. And so I'm going to slowly go through what I would normally do in 1 or 2 seconds. My eyes follow from the top of the pin all the way down to the ground level. I'm looking for anything that might touch the pin. As my eyes move down, it first encounters this bow-air grass, and so that becomes the first species in the top canopy column on the data form. And then as it follows down to the ground, the pin is resting on litter, so I record litter in the lower canopy. And finally it rests on bare soil, so that it's recorded as S in the bottom layer on the data sheet. So in the end, in 1 or 2 seconds, I would have come up to the point, let it drop, called bow-air, litter, soil, and moved on to the next point. It's very important when you're doing this method that the reader knows every species on the site before actually running the line. The reason for that is that you don't want somebody deliberating a long time at a point trying to figure out a species, because the longer you sit there trying to figure out what a species is, the more tendency you have to move the pin around, thus increasing the chance of a hit, and the more tendency that you have for the wind to blow the vegetation against the pin, which is also a bad thing. You're going to overestimate cover in that case. So it's important to walk up to a point, let the pin fall, make a reading instantly, and move on. One problem that we frequently encounter is the parallax problem when reading line point intercept. Parallax is when you're reading the line out of vertical, such as if my eyes are too far back behind the line, I would tend to project towards that side of the tape, which is incorrect. In this case, I would hit this soil plant when I shouldn't have originally. The other direction is if my eyes are coming too far over the tape, projecting back on that side. In this case, also I would have hit this plant where normally I would not. So you always want to keep your eyes right above the graduated side of the tape and aim to keep the pin as vertical as possible. In order to do this, you want to keep your whole body bent over almost at a 90-degree angle for the entire length of the line. This helps prevent this parallax problem, and pretend that a plumb bob is coming out of your eye and going down to the ground. Another important reason to stay bent over is being able to see small pieces of litter or other items on the soil surface. If you're down low to the ground, you're able to see things as big as a human hair, like awns of grasses and pieces of litter that size. However, if you're standing straight up, there's much less chance you're going to be able to see those pieces. So it's important to stay bent over and keep your head as close as comfortably possible while doing this method. This is how we record a basal hit, and a basal hit on a grass more specifically. If my point landed right here and my pin was dropped, I would call this bow-air, litter, and bow-air. And I'm going to pull back the grass to demonstrate this. If my pin had landed right here, I'm inside the column of that grass, so this is a basal hit on this black grama grass. If my pin would have landed right here, that is not a basal hit. One of the rules for determining a basal hit is if you draw an imaginary line around the outside of the culm of that grass and your point falls within that circle, it is a basal hit. So in that case, this is a basal hit, and that would not be a basal hit. This is how we would describe a point with no canopy cover or no soil cover. If the point had fallen here, you can see no canopy is touching the pin, and nothing is touching the pin at the soil surface. So we have none in top canopy column and S in soil surface column. This is how we describe litter in the line point intercept method. Litter is defined as organic material that is not rooted to the ground. In other words, this grass blade sitting on the soil surface. And also, woody litter is anything that is litter not rooted to the ground that is 5 millimeters or larger in diameter, such as this yucca stalk. So if my point had fallen here, I have no canopy, litter, soil. And if my point had fallen here, I have no canopy, woody litter, or WL in the lower canopy column, and S on the soil surface. The rock size class for the line point intercept method is defined as the 5 millimeter cutoff. Any rock that is 5 millimeters or larger is considered rock on the data form. Anything less than 5 millimeters is not considered rock. So if we look at this rock right here, it's right at the 5 millimeter cutoff. We would consider that rock, and it would go in as an R in the soil surface column. This rock here is too small. We wouldn't consider that rock. It's just part of this mineral soil. And these rocks are also larger. They would count as rock, or R, on the soil surface column. Another point to make, if my pin had landed on top of this rock, that counts as R in the soil surface column. Also, if this pin had landed next to that rock and touching it, it's counted as R in the soil surface column. But if the pin rests next to the rock but not touching it, of course that is not considered a rock hit. Occasionally you'll encounter a visible biotic crust adhering to the soil surface. In this case, we have a visible cyanobacterial crust showing up as black dots or black mats on the soil surface. Also included in this category are visible lichens. If your point lands on this, we call this no canopy and LC in the soil surface column. The way we describe multiple hits of the same plant or the same species is this. If my pin had dropped here, I count this ephedra only once, and it's the first time it hits right here. Because if I follow my eyes down, it hits this borage next, but then it hits the same plant, the ephedra again. And regardless if this is the same plant or another individual, it's the same species, and we only count that species once, and that's the first time it hits from a top-down point of view. So again, my eyes are following down, hits the ephedra once, I record that in the top canopy column, record the borage next, and I do not record the ephedra again. I continue down to the soil surface and call whatever is there. This is an example of hitting multiple layers of vegetation with the line point intercept. If my point had fallen here, I would call this mesquite first, then my eye goes down the pin, I hit the blackfoot daisy second, this woolly sumpweed third, litter, and then soil. So on the data form, I would have pergol, melee, eveday, litter, soil. It's important when making measurements in the line point intercept method to stay on top of the tape at all times. And sometimes this means getting inside thorny or spiny vegetation, such as this mesquite shrub. The reason for this is because you cannot make measurements standing out to the side like this. You have to be on top of the point in order to see straight down the pin. In this case, we would have spiffle, pergol, litter, soil. You have to put personal comfort aside sometimes to get a legitimate reading. Sometimes the wind creates problems when reading line point intercept, bouncing vegetation on and off the pin. It's important to take a quick visual snapshot to alleviate this problem. If I set the pin down and then take a quick look down the pin, determine whether or not the vegetation is touching, make a call, and move on. What I'm going to do now is read the line point intercept line at normal speed. Michelle is going to record for me. Notice she's standing back behind me, off the line, and able to hear me within earshot. So starting at point 1 of bow air over bow air, pista, litter, soil, crapo, litter, soil, none, soil, none, soil, spiffle, litter, soil, eveday, crapo, litter, soil, eveday, soil, none, soil, none, soil, leffy, eveday, litter, soil, pergol, litter, soil, pergol, soil, none, litter, soil, leffy, litter, soil, none, soil, none, soil, eveday, soil, arpu, arpu, none, litter, soil, gusa, litter, soil, pergol, mupo, litter, soil, none, soil, none, soil. What I'm going to do now is go down the line and describe some of the more interesting points along this line. At meter 1, I called bow air, bow air. How I did that is I dropped the pin, my hand slides down like my eyes did. I hit bow air canopy here, and then as you can see, it landed right in the middle of this bow air plant base. So bow air was how I called that point. At point number 2, I called pista, litter, soil. As my eyes came down, pista encounters the pin here. Moving down, it counters here, but I only count it once. Litter and soil. And this is a good time to mention that litter can occur in 2 different ways. Both beside the pin, and if the litter rests under or the pin goes through the litter, that also counts as a litter hit. At point number 4, we have none soil. As you can see, no canopy is hitting the pin, and it rests on bare mineral soil, just missing these pieces of litter. Point number 7 is an example of multiple hits of vegetation and multiple hits of the same species. Moving your eye down the pin, we encountered the Iva first, the croton next, another hit of Iva, but we only count it once from above, and then litter on the soil surface. So we had Iva, croton, litter, soil. Point number 14 is an example of none litter soil. As you can see, it just misses this bahia plant. Rests on the litter, also touches the litter next to it, and bare soils underneath. So none, litter, soil. Point number 22 is an example of dense vegetation, and also an example of how you can just barely hit a leaf even though you're inside the canopy of a shrub. As I dropped the pin, it hit some of these leaflets of the mesquite, and then as my eye goes down the pin, it hit some blades of this bush mealy grass, and then as it continued on down, I'll pull some of this grass aside. It rests on the litter and then soil. And so in this case, even though we're in the center of this shrub, I just barely hit a leaflet of the purgle, and then I hit great blades of the grass, mupo, litter, and soil. Point 37 is an example where you have to remove the vegetation to see what's at the ground level. In this case, we have two grasses, a 3-on and a black grama. Hits the 3-on first, hits the black grama next, and then normally I would think this would be resting on bare soil, but upon removing the canopy or pulling the canopy back, you can see that it's actually hitting the base of a black grama plant. So we have arpu, boer, boer.